Okay, so my screen is visible. Yes.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So first of all, I'll give you the description of your task 5. Okay. So basically, this is your heart disease analysis project. Okay. So in this project, you have to use all the skills that you have learned so far. Okay. And you have to analyze the heart disease data set, and in that you have to perform all the operations, like you have to use all the skills that you have learned. Okay, because your last part was the visualization part, so now we'll make a project. So your first project will be your heart disease. So in this, we'll first import the libraries, and we will import the data set. Then then we will analyze our variables. Okay, then we'll find the null values, and we have to handle that, and then we will visualize it. Okay, on depending on the questions that we're going to make. Okay, so this is your task 5, which is heart disease analysis. Okay, so I'm going to show my screen right now. Okay, yes, so this is your heart disease project. Okay, so in this, first of all, you have to import all the libraries that we need. Okay, first is numpy. This is for handling the numeric data set. Second comes the pandas library, which is the basic library we have to import, containing many inbuilt functions, basic functions. Third is matplotlib.pyplot splt. This is for visualization. Okay, in this there are many charts and plots are there. Then comes the C1 library. This is the advanced library. In this, more advanced plots and charts are there. Okay, then comes the percent matplotlib inline library. Basically, this library allows you to display the plots and visualizations directly within the notebook interface rather than in a separate window. Okay, so you can easily generate and view graph charts, other visualization, and then with your code. Okay, it just makes it convenient for the data analysis and exploration basically. Okay, so first of all, your duty is to import all the necessary libraries. Second task will be your importing the data set into your Jupyter notebook. Okay, so I hope till now you all know how to import a data set into your Jupyter notebook. So you have to use pd.read_csv function, and inside it you have to copy the location and title part of your data set. Okay, so this is how you can import your data set. Now we have to use some of the function for analyzing our variables. Okay, for seeing our column names and for taking the reference later for the visualization. Okay, so here is our first function, which is df.head. Okay, so you all know what head function will give you. Head function will give you first 5 rows of your data set. Okay, so this is your first 5 rows of your data set. Okay, so this is your first 5 rows of your data set, and these are the columns of your data set, which is age, sex, CP, CPA, chest pain, stress, BPS, cholesterol, FBS, and so on. Okay, so this is your first 5 rows. From this you can analyze your heart disease data set. Okay, then comes the tail function, df.tail function. So basically this tail function is the opposite of the head function. It will give you the bottom 5 rows of your data set. Okay, so tail function will give you bottom 5 rows of your data set. So these are the bottom 5 rows of your data set. Okay, now we'll look at the column names. Okay, now we'll look some of the column names. Okay, so by using the column dot values, here your all columns will present in the array form. Okay, so these are your column names. Okay, which is age, sex, CP. Okay, now we'll check for the null values. Okay, whether our data set is containing the null values or not, and if there are null values then we have to handle it. Okay, so now we'll checking for null values. So you have to use is any, means is null. Okay, is any dot sum, this function you have to use. So this function will tell you the sum of the null values in the particular column. Okay, so now in the result here you see 0 value in for each column. Okay, it means there are no null values in any of this column. Okay, so there are no null values in our data set. Okay, now we'll check the concise summary of our data set. Okay, so for the concise summary we have to use the info function. Okay, this info function will tell you the concise summary of our data set. So this is the concise summary. It will tell you the non-null counts. Okay, these are the non-null counts, and it will tell you the data type of each column. Okay, so all columns are end except the old peak column, which is float. Okay, so now we'll plot the histogram of all numeric values of all numeric columns. Okay, we will plot the histogram for just analyzing it more. Okay, so we are using visualization in this for analyzing our column names. So here we are plotting the histogram. So you all know for the histogram plotting we have to use hist function. Okay, and here bins equal 50 we have set. So basically what is bins first? Bins refers to the bins refers to the interval or ranges into which data is divided for analysis or visualization. Okay, it's like commonly used in histogram plots to group data points into specific intervals. Okay, so these are the interval or ranges, these are the bins. So if you see here, if I do 100, then you see the bins. It will take some time. Yeah, so your interval or ranges is increased. Okay, so these are your bins. Now comes the grid. So what is grid? So grid is basically refers to a set of evenly spaced lines in the background of your plot, of your histogram. Okay, if you do here true, then you'll know that what I'm speaking. See, this is your grid spot. Okay, so means evenly spaced lines or sometimes dots. Okay, it forms a network in the background of your histogram. Okay, so this is your grid. So if you want grid, you can use here true. Otherwise, you can use here false. Okay, and I'm changing this to again 50. Okay, so this is your bins and grid, and figure size is your the length and breadth, the figure size of your histogram. Okay, so this is your 20 and 50. Okay, so now these are the histograms of your all columns: age, set, CP, old peak, okay, target. So these are the histogram. So now we'll generate a descriptive statistics of our data set by using the describe function. So by using the describe function, you will see the descriptive statistics of your data set. Okay, so these are the statistics, descriptive statistics of all your column here. Okay, now what we have to do, okay, so now we have to make some of the questions. Okay, here I have taken 4 questions by myself only. You have to take minimum 7 or maximum 10 you can go. Okay, so these are the 4. You have to include these questions in your task. Also you have to do minimum 3 by yourself and maximum 5. Okay, so means total question should be 7. Okay, total question should be minimum 7 and maximum 10 you can take. Okay, So these are the questions. So you have to solve your questions by using the appropriate functions. Then you have to visualize it. Okay. Then you have to visualize the answer. Okay. So here first question. Now we'll find the answer of first question. So here first question is how many people have heart disease and how many people doesn't have heart disease. Okay. So for getting the values, we are using the target column. Okay. Target column. See, this is your target column. So in this, the target column contains only two kinds of answer, which is 0 and 1. So here 0 represents the people don't having any heart disease and 1 represents people having heart disease. Okay. So for our first question, we are using the target column for getting the values. Okay. So you have to use target dot value underscore count. This function value underscore counts for calculating the value of 1 and 0 in the target column. So this is your value. It means 526 people are having heart disease. Okay. And 499 people isn't having any heart disease. Okay. From our data set. This value is from a data set. Okay. Now we'll plot a bar chart for the same answer. We are using the answer, okay, of this. Then we are plotting the by using the dot plot function. And here kind is bar and color we have set is orchid and salmon. Okay, so we have set the color of our bar chart, which is orchid and salmon. So here you know the title y label, x label, y label, how to set it. Okay. So this is your heart disease values. So here one represents the orchid color represents the number of people having heart disease, and here the salmon color represents the people no having any heart disease. Okay. Now we're plotting a pie chart for the same answer. Okay. Now this is your second visualization for the same answer. It depends on you how many how many visualization you want to do for one answer. Okay. And which kind of visualization you want to do. Okay. So you have to be careful before using any visualization. It may not be crowded. Okay. So yes, so this is your pie chart for the same answer. Here kind is your pie and figure size is 8, 6. So you can increase to your figure size, but this is appropriate actually. So yes, so you can, yes, so this is your bigger size of pie chart. Okay, this size is appropriate. So this is how you can alter the size of your charts. Okay. And here legend is disease and no disease. Okay. So here blue color represents the people having heart disease and orange color represents the people not having any heart disease. Okay. So this is your pie chart for the same answer. Now here 0 represents female and 1 represents male in sex column. Okay, sex column also having two answers only in 0 and 1. So in that 0 represents female and 1 represent male, and in target column 0 represent no disease and 1 represent disease. Okay, so now here we are checking that how many male and female are in the data set. Okay, so for the male and female we are using the sex column. Okay, then sex dot value underscore counts. So here sex value tells you that 713 people are male here in our data set and 312 are females in our data set. Means the male ratio is double than a female ratio. Okay. So now we'll plot a pie chart for the same answer. Okay. So this is your title legend. You know how to set. So this is your male and female ratio. See, blue color represents the male ratio and female. Then this orange color represents the female ratio. So from this pie chart, the the conclusion is very clear that male is double than the female. Okay, in our data set. Okay, so now let's find the answer of our second question now. Okay, so which is people of which sex has most heart disease. Okay, So for this we are using the cross tab function. Okay, so what is cross tab function in data analysis? Basically, this is a short form for the cross tabulation. Okay, this is a useful tool. Okay, for analyzing the relationship between two or more categorical variables. Okay, it creates a cross tabulation table. Okay, it creates a cross tabulation table that display the frequency or count of occurrences. This is the count of occurrences. Okay, so this is your cross tabulation. So here we are making the cross tabulation between the target column and sex column. So here 0 represents the female part and 1 represents the male part. So this cross tabulation is telling you that female part, that females, 86 number of females having no heart disease and 2 to 6 number of females having heart disease. And this tells you that 413 number of males having no heart disease and 300 number of males having heart disease. Okay, so this is clear from a cross tabulation. Now we'll plot a count plot for the same answer. Okay, so here we have taken the X is target column, then data is DF, okay, and hue is sex. So basically hue parameters allow to introduce an additional variable to your plot. Okay, it's like hue, here is hue equals sex. So sex is of two kind, which is female and male. So hue will set the different color for the two sex. Like female color will be different and male color will be different. So that we can easily see the difference between both. Okay, so this is your title and this is your X level. Okay, this is how you can set the X level. So this is your heart disease frequency for sex. Okay, so from this count plot we have concluded that number of male is more than double in our data set than female. Obviously it is clear that male ratio is double than the female ratio. Okay, also the more than 45% male has heart disease and 75% female has heart disease. Okay, so this is the 45% male has heart disease and 75% female has heart disease. Okay, it is clear. Now we'll move to our question 3, which is people of which sex has which type of chest pain most. Okay, so for counting the values for different chest pain, we are using the CP column. CP column is of chest pain column. Okay, so we are calculating the value. So by calculating the values, here is the result. So here are four kinds of chest pain, which is 0, 1, 2, 3. Okay, so here 497 people having 0 kind of chest pain, 284 people having second kind of chest pain, 167 people having one kind of chest pain, and 77 people having third kind of chest pain. Okay, so this is your answer of people of which sex has which type of chest pain most. Okay, no, this is for that only how many number of people having which kind of chest pain. Okay, so now we'll plot a bar chart for it. Okay, so we are using the dot plot function and here kindness bar, and here we have color set, which is salmon, light sky blue, spring green and khaki. Okay, so here plt dot title is for setting the title, which is test pain type versus count. So this is your bar chart for the above answer. Okay, now we are doing the cross tabulation between the sex and chest pain column for solving our answer, like which sex has which type of chest pain most. Okay, so this is your cross tabulation, and 0 represents female and 1 represents male, so it will give you the cross tabulation of the sex and CP column. Okay, so from this it is clear that this these numbers of females having this kinds of chest pain mobs and these numbers of male having this kinds of chest pain mobs. Okay, so now we'll use the cross tabulation of this and we'll plot a bar plot for the above answer. Okay, and here color we have set as coral, light sky blue, plum and khaki. Okay, so you can set any color. Okay, so you can set any color for just making your plot visually appealing. Okay, so here title is type of chest pain for sex and its label is 0 for female and 1 for male. So this is for female part and this is for male part. Okay, so this is your type of chest pain for sex. This is your bar plot for it. Okay, so from this plot we have concluded that most of male has type 0 chest pain most and least of male has type 4 pain, and in female we have concluded that in case of female type 0 and type 2 percentage is almost same. Okay, so yes, so now we'll move to our question 4. Okay, which is people with which chest pain are most prone to have heart disease. Okay, so here we are making the cross tabulation between the CP and target column. Okay, and here is your result. So here we'll plot the count plot for the above answer. So here X is CP, data is DF, and Q is target. Okay, so target is two types of target in our data set. So you will set different color to our different targets. So this is your count plot. So from this count plot, we have concluded that most of people who has type 0 chest pain has less chance of heart disease. Okay, and we see the opposite for the other types. Okay, so yes. So now let's take look at our age column. Now we'll take look at our age column. So we'll create a distribution plot with normal distribution curve. Okay, so what is distribution plot? Okay, so distribution this this plot is the short form of the distribution plot. Okay, so basically it is used to display the distribution of a single numerical variable. Okay, so this is your single numerical variable which is age. Okay, so it combines a histogram, okay, with a kernel density estimate. This curve represents your kernel density estimate. Okay, and it provide a comprehensive view of the data distribution basically. Okay, so this is your displot. So for using the displot you have to use displot function. Okay, then here X is age because we have to make a displot of age column. Data is DF, bins is 30, bins means interval and ranges. KD is true, okay, which means kernel density estimate is true here. And if you don't want your KD, then you can use here false. Now you'll see that curve is removed from our displot. Okay, so that is KD. Okay, so now from this plot we have concluded that 58 to 59-year-old people are most in our data set. Okay, so yes, now let's plot another distribution plot for maximum heart rate. For maximum heart rate we are using the Thalage column. Okay, we are plotting this plot. Data is DF, wins is 30, KD equal to, and color here we have said chocolate. So this is your chocolate color plot of the Thalage column. Okay, so from this plot we get a clear overview about the maximum rate by Thalage column. Okay, so yes, this was all your heart disease project. Okay, so I'm going to repeat again. I'm going to brief you one. I'm going to tell you the brief once again. So here, first we have to import all the necessary libraries that we need. Okay. Then you have to import your data set. Then you have to use some of the function for analyzing your variables. Okay. Then you have to check the null values, and if there are null values, then you have to handle it by the three methods that we have learned so far. Okay. Then we have to show the concise, summary, and descriptive statistics of your data set. Then you have to visualize your all columns by using the histogram. Okay, it will be more appealing. Okay, so then after analyzing your variables and columns and by dropping the null values, okay, you have to make, yes, so you have to make first question, so minimum 7 and maximum 10 till you can go. Okay, so these are the four questions. You have to add more in this. So you have to solve your question by giving you the answer by using the appropriate function. Then you have to visualize your answer. Then you have to visualize your answer of each question. This is the first visualization, and this is your second visualization for the answer one. So it depends on you what kind of plot you want to choose, okay, and how many visualization you want for particular answer. So this is how you have to solve. You have to solve by using the functions, then you have to visualize your answer, okay, answer of your question. So yes, so this is how you have to make a project of the heart disease analysis, okay. So I hope this is clear.